Hello, everyone. A very good morning. Welcome to Aerospace Now. Today, we're going to present on the topic exoplanets. This is our crew consisting of 4 members. I am Rakshan Kumar, CEO of Aerospace Now. Sanjay, who is the MD of Aerospace Now. Riyansh Vora is the CTO. And Naman, who's an employee. This is our company's logo. And very thanks to Vice Chancellor Aerospace and Mr. Jagadish Khanna for supporting us creating this fully registered company. Let's dive deeper into the topic. What are exoplanets? An exoplanet or an extrasolar planet is a planet outside the solar system. In the 1980s, Earth and the other planets orbiting the Sun were the only planets known in the universe. But since then, astronomers have found thousands of planets circling the stars. These planets are called as extrasolar planets or the exoplanets for short. Astronomers have discovered more than 3,500 exoplanets by 2018. Some scientists have found signs that there may be even more planets outside the solar system. Many of the first exoplanets scientists discovered were huge gas giants. However, more research is still needed to confirm that these exoplanets exist. There are 4 different types of exoplanets: gas giants, Neptunian, super Earth, and terrestrial. Example: Kepler 452b, Kepler 16b, Pollux b, etc. These are types of exoplanets: terrestrial, Neptunian, gas giants, and super Earth. Terrestrial, Earth-sized or small, then mostly made of rock or metal. Some could possess oceans or atmosphere and perhaps other signs of habitability. Neptunian, similar in the size of our own Neptune and Uranus, with hydrogen or helium-dominated atmosphere. Many Neptunes are not found in our solar system, but are smaller than Neptune, but larger than Earth. Gas giants, the size of Saturn or Jupiter, are much larger. They include hot Jupiters, scorching planets in close orbits around their stars. And finally, super Earth, typically the terrestrial or rocky and more massive than Earth, but lighter than Neptune. They might or might not have an atmosphere. A few pics of extrasolar planets. So this is me. Thank you so much. And passing on discoveries to Sanjay.
Hey all, my name is Sanjay and I am the MD of Aerospace now. So now we're going to see the discoveries or some discoveries that our astronomers have made on exoplanets, or they have found some exoplanets that are not in our solar system. So astronomers found the first 2 exoplanets in 1992. These exoplanets look nothing like Earth. They are completely different. They orbit a dead star. When a star dies, its center sometimes collapses into a dense glowing cinder. This type of leftover star is very different from the Sun. Scientists were surprised to find planets orbiting these remnants. 3 years later, scientists found an exoplanet moving around a star like the Sun. But this exoplanet is quite different from the Earth. The exoplanet travels around its star in only 4 days. So Earth rotates around our Sun in 365.25 days. But this exoplanet just travels in 4 days around its Sun or star. This exoplanet is much hotter than Earth. In addition, the exoplanet weighs as much as Jupiter. That means it is more than 300 times as massive as Earth. AKELT 9b, the hottest exoplanet discovered so far, is even warmer than some stars. Discovery's continuation. This type of large hot planet is known as hot as Jupiter. During the next decade, astronomers found many other large hot exoplanets. Some are so close to their stars and their surfaces are hot enough to melt iron. Earth ever since, as it orbits, the telescopes takes pictures of planets, stars, and other objects in space. Because the telescope is above the Earth's atmosphere, the pictures are much clearer than pictures taken from the Earth's surface. Scientists study the pictures to learn about outer space. Sometimes they find exoplanets in the pictures. The exoplanets look like very faint glowing objects around the stars. Again, discoveries. So far, Earth is the only planet scientists know of that has life. But discoveries of 2000s came closer to finding planets that are like Earth. A few of these planets are the same size as Earth. Some have signs of an atmosphere. They may even have water. Water is very critical for the development of life on Earth. Scientists now know of more than 50 exoplanets that may be able to support life. So when the Earth goes extinct, we can still have 50 more planets to survive on. The support. The Hubble telescope orbits 354 miles, which is around 569 kilometers above Earth's surface. In the mid-2000s, scientists began finding large exoplanets that are farther from their stars. Some of these planets were much farther from their stars than Pluto is from the sun. So as you all know, Pluto is a dwarf planet now. It is considered as a dwarf planet. It is the 9th planet, dwarf planet. It is very far from the sun. It's also very cold. So some of these planets are much farther from Pluto. These exoplanets were found using the Hubble Space Telescope. The Hubble Space Telescope was launched into space in 1990. It has been orbiting Earth ever since. As it orbits, the telescope takes pictures of planets, stars, and other objects in space. Because the telescope is above Earth's atmosphere, the pictures are much clearer than pictures taken from the Earth's surface. Because it is taken from the space, not from Earth. Scientists study the pictures to learn about outer space. Sometimes they find exoplanets in the pictures, and they also look like faint glowing stars. Shifting starlight. To find most exoplanets, scientists look at changes in starlight. A planet does not have to create its own light. Instead, it reflects the light from a star that orbits. Even our moon reflects the light from the moon. Sun. Scientists can sometimes look for changes in straight starlight to find exoplanets because of gravity. A planet and its stars pull on each other. Gravity's effect on two objects depends on each object's mass. For example, the sun is more than 300 times more massive than Earth. It's not 300, it's about 3 lakh. massive than Earth. The exoplanet uh, GJ436b is approximately the same size as Neptune. The sun's pull on Earth causes Earth to orbit. Earth also pulls on the sun, but Earth is tiny compared to the sun. It pulls does not have much effect on the sun. The sun does not move nearly as much as Earth's do. Earth.
Thank you so much. Manny. So moving on to the next continent. Naman, the stage is all yours, buddy.
Thank you, Rakshan. Continuation of shifting stars. Most exoplanets are much less massive than the stars they orbit. For this reason, an exoplanet's pull is so small that astronomers will not see the star move. But the exoplanet's pull makes the starlight appear a slightly different color. Scientists can detect this change even from far away. The change tells scientists that an exoplanet is pulling at a star. Scientists can study these changes in starlight to determine an exoplanet's mass. Exoplanets that are more massive cause larger changes. Less massive exoplanets cause smaller changes. When the first exoplanets were discovered, at most exoplanets take a few hours to cross in front of a star. Scientists use this method. It helped them determine that the planets were as massive as Jupiter. Jupiter is 318 times as massive as Earth. Strength of gravity also depends on the distance between a planet and its star. An exoplanet that is near its star pulls on the star much more than a similar sized exoplanet that is farther away. Its pull causes a greater change to the starlight. By studying the starlight, scientists can estimate how far an exoplanet is from its star. By the mid 2000s, scientists had found a few hundred exoplanets, but most were too massive to be much like Earth. Plus, compared with the stars they orbit, most exoplanets give off very little light. So it is rare for exoplanets to be spotted directly. Astronomers needed a different method to find Earth-like exoplanets. The Kepler telescope. The Kepler Space Telescope made this possible. The large telescope was launched into space in 2009. It orbits the Sun and looks out at stars across the galaxy. Scientists use the Kepler Space Telescope to find smaller exoplanets. As an exoplanet passes between its star and the telescope, the exoplanet blocks a small amount of the star's light. The Kepler Space Telescope detects these tiny dips in starlight. When scientists notice regular dips in a star's light, they know an exoplanet is present. From top to bottom, the Kepler Space Telescope is 15.3 feet or 4.7 meters long. To calculate how far that exoplanet is from the star, they measure how often the dips happen. Each dip means the exoplanet has completed one orbit. A planet that is farther away will take longer to move around its star. For this reason, exoplanets with bigger orbits have less frequent dips in light.
So much, Naman. Moving on to the next. Riyansh, the CTO of Aerospace now. This stage is all yours, buddy.
Thank you so much, Rakshan. So now let's understand how these astronomers calculate the distance from the Earth to the exoplanet. So the astronomers can also take estimate of their exoplanet size. To do this, they measure how long the planet takes to cross in front of or transit its star. And they study how much light the exoplanet blocks when it passes between the star and a telescope. A larger exoplanet will most starlight as it crosses in front of the star, while a small exoplanet will block some amount of less light than a large star. So, an exoplanet's distance from its star also affects how much light it blocks. So, an exoplanet will also block more light if it is close to the star and less light if it's away from the star. So, based on the size and the distance, the astronomers can finally conclude that long is the how, how long is the planet, or what is the diameter or the radius of the planet. Now let's understand what is a transit method. So the transit method also makes it possible to study the atmosphere of the transiting planet. When the planet transits the star, the light from the star passes through the upper atmosphere of the planet. By studying the higher resolution stellar spectrum carefully, one can detect elements passing in the planet's atmosphere. Planets may give themselves away when they pass in front of a star and a dim of its light. The passage of a planet between a star and an Earth is called transit. Such a dimming is detected at regular intervals and lasts a fixed repeated length of time. Then it is very likely that another dimmer object is orbiting the star. Some of these transiting objects might be small, dim stars, in which case the pair is called eclipsing binary, but most of them are planets. So now it's a continuation of the same transit method. Astronomers glean some very important information about planets detected using this method. As the planetary transit is a periodical in nature, astronomers can determine the planet's orbital speed. An additional bonus of the transit method is that it can hint of the planet's atmosphere making it, if it has one. We can also learn about an exoplanet's atmosphere during a transit. As it transits, some light will grow through its atmosphere, and that light can be analyzed to determine what different atmospheric elements influence its particular dispersion. Atmospheric composition is important to determining habitability. So exoplanet and transit method. The total number of all exoplanets 4,521. Confirmed discovered by Kepler 2,402. Kepler project candidates yet to be confirmed 2,361. Sorry, my bad. Confirmed planet discovered by K2 467. K2 candidates yet to be confirmed 884, 89. Confirmed planets discovered by TESS 155. TESS projects integrated to archive 4,511. Current date TSSS project candidates at ExoFOP 4,511. TESS projects candidate yet to be confirmed 3051. Now, let's conclude this presentation with a did you know fact. Kepler 22b was the first planet outside the Earth to known of having an atmosphere. This Kepler 22b is also an exoplanet, but it is the first planet outside the Earth. Even the other planets in the solar system, they don't have an atmosphere. But this Kepler 22b can be a future Earth for people to live in because it has a complete different atmosphere.
Yeah. Thank you so much, Riyansh. And I hope we conclude here. Thank you so much, everyone. Thank you so much, viewers. And the ones who actively participated in this presentation. Naman, Riyansh, Sanjay, and the Vaishastra team. Thank you so much.